Preamble. The artificial intelligence industry is undergoing a structural reckoning. A generation of startups built their commercial foundations on a precarious assumption that the friction of accessing a large language model's raw API would remain high enough, long enough, to sustain a business. It did not. What followed was a wave of pivots, dissolutions, and hard lessons. Along with a clarifying insight about what it genuinely means to build defensible value in an ecosystem dominated by a small number of extraordinarily well-capitalized technology firms. This essay is addressed to those on the intellectual front lines of this conversation: academicians researching AI market dynamics, IT consultants advising organizations on technology strategy, and university graduates preparing to build within or critically evaluate the AI-powered enterprise landscape. 1. The anatomy of the wrapper. In technology circles, the term wrapper has acquired a specific and somewhat pejorative meaning. A wrapper is any commercial product that overlays a simplified user interface onto an existing AI API without contributing proprietary value that is meaningfully difficult to replicate. The critical distinction lies in that final phrase. Excellent interface design has genuine worth. But a product whose entire competitive advantage consists of presenting someone else's intelligence in a polished format is structurally fragile, because the moment the underlying model provider offers a comparable interface, the wrapper's commercial rationale collapses entirely. The historical record confirms this pattern. Between 2021 and 2024, scores of companies launched AI-powered writing assistants, customer service chatbots, summarization utilities, and code completion tools. All of them, functionally, thin veneers atop the APIs of OpenAI, Anthropic, Google, Meta, or xAI. These products were not fraudulent, they were premature. Their founders correctly identified that these APIs were powerful but initially difficult to access. The value they offered was the removal of that friction. The error was in treating friction removal as a durable competitive moat. Friction is a temporary property of immature ecosystems. As foundation model providers matured, releasing consumer chat interfaces, enterprise deployment platforms, and purpose-built vertical tools, the friction evaporated. The wrappers, suddenly redundant, either dissolved or sought reinvention. This dynamic is not unique to AI. The same pattern played out in the early web, the smartphone era, and the early cloud period. What distinguishes the AI iteration is its speed, and the concentration of capability within a handful of providers whose resources, computational, financial, and in research talent effectively preclude competitive parity at the model layer. 2. Why model providers always expand. Understanding why wrappers fail requires understanding the economic logic driving foundation model providers to expand aggressively into adjacent product spaces. Training and maintaining frontier-scale models is enormously capital-intensive. The marginal cost of serving an additional inference is low, but fixed costs are staggering. This cost structure creates relentless pressure to capture as much of the value chain as possible. Every layer of the product stack that a third-party wrapper occupies represents revenue the model provider is not capturing. The rational response, consistently observed, is vertical integration. What is being commoditized is not all application layer value, but specifically the value that derives from access alone, the economic premium of being an intermediary between a raw API and a user who lacks the time or technical literacy to access it directly. As model providers invest in ease of use, that premium approaches zero. There is a corollary frequently underappreciated: the success of a wrapper product can accelerate its own displacement. A wrapper achieving meaningful market traction effectively demonstrates to model providers the existence of a demand signal in a particular vertical. The provider, observing this signal, can invest in replication with the advantages of deeper model access, superior brand recognition, and platform integration. Several documented cases from 2022 to 2024 follow this precise pattern. 3. The first pillar, proprietary data. Against this backdrop of structural vulnerability, the first pillar of sustainable differentiation is proprietary data, not merely data a company happens to possess, but data that is unavailable or materially difficult to replicate at scale, directly relevant to improving model performance on consequential tasks, and controlled in ways that prevent straightforward appropriation by competitors. Foundation models are general-purpose instruments. Their training data is vast but necessarily broad. The gap between general world knowledge and specialized domain knowledge is precisely where proprietary data creates value. A company possessing high-quality, well-labeled, domain-specific data and the infrastructure to leverage it through fine-tuning or retrieval-augmented generation creates a product that a general-purpose model cannot easily replicate. Consider the examples. A structured database of physician-annotated medical records, a curated repository of jurisdiction-specific legal case law, or exclusive data sharing agreements with industry bodies or academic institutions. These are epistemic assets of genuine and enduring scarcity. They cannot be synthesized from general-purpose training corpora. They represent knowledge that belongs to specific operational contexts, and that grows more valuable, not less, as it is refined over time. One caveat deserves emphasis. The possession of proprietary data is insufficient without the organizational capability to exploit it. Static data becomes stale. Defensible advantage derives from the ongoing, dynamic process of data curation, augmentation, and continuous refinement, combined with attentiveness to the rapidly evolving legal landscape governing data privacy and usage rights. 4. The second pillar, deep workflow integration. The second pillar is perhaps the most operationally demanding, and therefore the most reliably defensible, deep workflow integration, the embedding of AI capabilities so thoroughly within existing operational processes that the product becomes practically inseparable from the work itself. Wrapper products occupy a peripheral position in users' workflows. They are tools a user accesses, opens a tab, types a query, copies the output, rather than tools woven into the fabric of how work is actually done. This peripherality makes them substitutable. If a comparable product becomes available at lower cost, the switching cost is minimal. The user simply navigates elsewhere. Deep workflow integration inverts this dynamic. A product configured to communicate with an organization's ERP system, CRM platform, proprietary data warehouses, and industry-specific compliance tools creates switching costs that are genuinely substantial. Extracting such a product requires not merely choosing a different vendor but reconsidering and rebuilding the integrations that connect AI capability to operational reality. This is expensive, disruptive, and time-consuming. It is a genuine moat. The analogy to legacy enterprise software is instructive. The longevity of technically unremarkable enterprise vendors is explained almost entirely by integration depth. Organizations continue using these products not because they are the best available option, but because the cost of extraction exceeds the benefit of migration. AI ventures that achieve this kind of embedded position are pursuing the same logic with a significantly more powerful underlying technology. The third pillar, niche specificity. The third pillar is niche specificity, the deliberate decision to serve a narrowly defined domain with exceptional depth rather than attempting to address broad, general-purpose needs. This runs against the intuitions of growth-oriented investors who prize large addressable markets, but it is strategically sound. Foundation model providers, by commercial necessity, focus on breadth. Their development roadmaps are shaped by the needs of the largest possible markets. This breadth is also, from a startup's perspective, an opportunity. Any domain sufficiently specialized, where terminology is arcane, workflows are idiosyncratic, regulatory environments are complex, or knowledge acquisition is costly, represents a space where general-purpose breadth becomes a liability and domain depth confers decisive advantage. Radiology, maritime law, structural engineering, pharmaceutical regulatory affairs, derivatives risk management, these are not domains a general-purpose AI can serve with genuine expertise without significant domain-specific adaptation. They are, however, domains where the economic value of AI assistance is potentially very high, and where the density of specialist knowledge required to build genuinely useful tools creates a natural barrier to casual replication. Niche specificity should not be conflated with small market size. The relevant metric is not the number of users, but the value delivered per user and the competitive intensity in the segment. A product serving the global population of customs compliance specialists may address a numerically modest user base while accessing very substantial economic value. 6. The synergistic architecture of durability. These three pillars are not independent strategic options. In their most robust form, they are mutually reinforcing. A company serving a specific niche acquires, through that service relationship, access to domain-specific operational data unavailable to general-purpose providers. That data improves model performance in niche-specific ways. As performance improves, the product becomes more deeply embedded in workflows. That embedding generates more operational data, which further improves performance, which deepens integration further. The three pillars become a virtuous cycle. A proprietary learning loop that compounds over time and becomes progressively more difficult to displace. The implication for strategy is significant. An AI venture pursuing defensible differentiation should optimize not for user acquisition breadth, but for the intensity and quality of the feedback loop between product use, data generation, and model improvement within its chosen niche. Summary: the wrapper problem in AI is real, documented, and structurally predictable. Its resolution does not lie in building better wrappers, it lies in transcending the wrapper model entirely. Proprietary data creates knowledge advantage tethered to real-world contexts that cannot be synthesized from general-purpose training corpora. Deep workflow integration transforms an AI product from peripheral utility to embedded operational capability, substituting genuine switching costs for illusory stickiness. Niche specificity narrows the competitive surface to a domain where depth of understanding creates genuine advantage over breadth-oriented platform providers. Together, these three pillars constitute not merely a strategy but an epistemology, a particular understanding of where value resides in the age of machine intelligence. Value does not reside in the interface. It does not reside in the act of accessing a powerful model. It resides, as it always has, in the knowledge, relationships, and operational capabilities that are genuinely difficult to acquire and therefore genuinely difficult to displace. Those who internalize this understanding early will find themselves not threatened by the extraordinary capabilities of foundation models but empowered by them. Those who do not will find themselves offering, at increasing cost and diminishing reward, a more aesthetically pleasing door to a room the landlord increasingly insists on entering himself.